All right, these are the notes for 4-6, absolute value in open sentences. And another word for open sentences is meaning more or less just inequalities. So our objective today will be to find the solution sets of absolute value within open sentences, or inequalities. We'll represent our answers both algebraically and graphically. Now the first thing we're going to talk about here are different ways to represent solution sets on number lines. I just got a few different ways that you'll see inequalities or equalities written here, and I'm just going to talk about what their solution sets would look like when they were graphed. So the first one here, under graph the solution sets, we have x equals 5. So if I wanted to graph that on a number line, and we typically don't graph just single values on here, but if we were going to, it would be, we'd have a number 5 on there. You could even put like a second value, say 0, so we know our number line is going the right way. And we would put a closed circle. Remember, this closed circle here represents the shading above 5 here, or we'd say it's 5 is inclusive, or it's included in the solution set. But our answer is just x equals 5. Now, when we move over to the right here and look at the second one, and we'll call this letter B. So this is like letter A. We'll call this letter B. With letter B, we're talking about the absolute value of x equals 5. So there are two numbers that are 5 units from 0 on the number line, right? If we put 0 here, there's the number 5 here. 5 is 5 units from 0. And if we go 5 units the other way, negative 5 is also 5 units from 0. So we could count, to the right from 0 and get 5 is one of our solutions. And the absolute value of 5 equals 5, right? So we'd have 5 equals 5. We know that was true. And then our second solution there, negative 5, because it's 5 units from 0 also. So we could say the absolute value of negative 5 should equal 5. And we get 5 equals 5. Both of those are true. We know that that is correct. So absolute value, we've got two solutions in our solution set. Looking at what we'll call letter C now, we have the absolute value of x is going to be greater than or equal to 5 units from 0. So if we think about, we have 0 on our number line here. We already know that 5 is 5 units from 0. And since we're talking about greater than or equal to, we know that that's still part of this solution. Oops, sorry, I switched my controls there. Now we're back. We have negative 5 is also 5 units from 0. Now, this inequality here is also asking for everything that's more than 5 units from 0. So ask yourself here, if is any value, let's say like, 1, 2, 3, 4, any of those numbers more than 5 units from 0? Or are we talking about the things on the outside here, like 6, 7, 8, and so on there? Okay, so like if we put in 6 into our absolute value brackets there, is the absolute value of 6 greater than or equal to 5? Well, the absolute value of 6 is 6, and yes, 6 is greater than or equal to 5. So we know that all the values outside here are going to make this true. But we also have some more values that will make it true. If you think about, just like 6 had an absolute value of 6, which was greater than or equal to 5, the absolute value of negative 6 is also going to be greater than or equal to 5, because the absolute value of negative 6 would be positive 6, which is greater than or equal to 5. So we're also going to have an arrow going out to the left here. Okay, so our answers are going to be x is less than or equal to negative 5, or x is greater than or equal to positive 5. So those are representing all of the values on the number line that are more than 5 units from 0. So if you think back to the last lesson, we had some examples where we had values that were like under one arrow on one side of our number line, or we had the shading on the other side going the other way, and we could represent values there that would make our inequality true from two different parts there. This is like a disjunction. because our solution could be over here on the left side, less than or equal to negative 5, or it could be over here on the right side. Now let's look at where the absolute value of x is greater than 5. Well, the only difference between letter C and what we'll call letter D here is we're just going to exclude the values of 5 and negative 5. So we're going to say here that we're going to have negative 5 as a boundary point, positive 5 as a boundary point. We'll put 0 on there too, but now we're going to have an open circle going to the right, and on the left side an open circle going to the left. This would be x is less than negative 5, or x could be greater than 5. So once again, another disjunction, because our answer could be over on the right side or on the left side. So if we have greater than or equal to and greater than are like disjunctions, that must mean that down on the bottom here, I'm going to change colors when I talk about these ones, where we have the absolute value of x is less than or equal to 5, like on letter E here. If our absolute value of x is less than 5 units or equal to 5 units from 0, we're going to be talking about 5, negative 5, and everything that's less than 5 units from 0. So if 5 and negative 5 are still just 5 units from 0, anything less would be all these values in between here. Now, how do we represent that? Well, this is like a conjunction. Right? Because our answer is going to have to be greater than or equal to negative 5 as we go this way, and it would have to be less than or equal to positive 5 going that way, and they have to represent both of them there. So we're going to take this and we're going to say x has to be greater than or equal to negative 5, and x has to be less than or equal to positive 5, which can be written as a compound inequality. We put our boundary point at negative 5 is less than or equal to x, and x is less than or equal to positive 5. So that would be our solution set for the absolute value of x is less than or equal to 5. And if less than or equal to 5 is a conjunction, then that means less than 5 would have to also be a conjunction. We're just going to exclude the values of 5 and negative 5. So let's put those boundary points back on here, but this time we're not going to include them. We're going to have open circles. I'll put 0 on there too, just because we're talking about the distance from 0. And we're going to say here that in between, these are all the values that are less than 5 units from 0. So we're going to say, if we think about the inequality on the left, that would have been x is greater than negative 5, and x is less than positive 5. Or rewritten as a compound inequality, negative 5 is less than x, and x is less than 5. Now to check any one of these here, we could always just take a value of x and plug it in. Let's just do this last one here because I feel bad not talking about how to check your work, because you need to know how to do that. So if I took a value, let's just say 1, right? Number 1. If I plugged it in to my original problem there, the absolute value of 1 is less than 5. Well, the absolute value of 1 is 1, and 1 is less than 5. That makes it true. Okay, if you take it there on any one of these and take a value and plug it back into the original problem that we started with, then that should make it a true statement. That was letter F, the last one there. Sorry. All right, let's move on to a couple examples now. Letter C, or slide C, it says solving absolute value inequalities. It says solve each inequality and express the solution on a number line. All right, so to solve these, we need to think about what the statement says. So the first one, we have the absolute value of 2x plus 5 is less than 3. So we're talking about everything that's less than 3 units from 0. So if you think back to our notes on the other side there, anything that was less than or equal to, when our variables on the left are going to be conjunctions. And I'll talk to you in class about a way here, just kind of a play on words, to remember which one is which. I just spelled it wrong again, and okay, hold on, timeout. There we go. Conjunctions. All right. So I will teach you a way in class if you want that has kind of a little play on words to remember which one's which. But all we're going to do here is to set up our two inequalities to get our graphs is we're going to take what we've got. With the absolute value of 2x plus 5 is less than 3. The first thing we're going to do is just rewrite it without the absolute values. So we have 2x plus 5 is less than 3. That's going to represent one of our inequalities on there. And because this is a conjunction, I'm going to say and. I'm going to create my second one, which is just going to be 2x plus 5. And remember the opposite here, if we're talking about less than 3, right? If you're thinking about less than 3 on a number line, the opposite of that, let me just draw a little number line here. If this is 3, we're talking about less than 3. The opposite of 3 is negative 3, and then the opposite of less than would be greater than. So our second inequality here will be 2x plus 5 has to be greater than negative 3. And now we're just going to solve each of those here. So we subtract 5 from each side. We're going to get 2x is less than negative 2. We divide by 2. We get x is less than negative 1. And on this side, we're going to subtract 5. We've got 2x is greater than negative 8. We divide by 2 on each side, and we're going to get x is greater than negative 4. So our value of x has to be less than negative 1 and greater than negative 4. If we put those onto our number line here, we've got negative 4 on the left, negative 1 on the right. Negative 1 is greater than negative 4, so it has to be on the right side. Let's graph x is greater than negative 4. So we're going to have an open circle, and it will go to the right. And x is less than negative 1 is going to be an open circle at negative 1, and it's going to go to the left. Because this is a conjunction, we need to have all the values that make them both true. So again, this goes back to looking at the intersection of the two graphs, which is going to be everything there where they overlap. So we're going to say here, it's greater than negative 4 and less than negative 1. So x is greater than negative 4 and x is less than 1, which is going to be our solution set written algebraically. If we take any value from negative 4 to 1, let's say, like, to check it, let's do x, let's say x equaled 2. I'm sorry, let's say negative 2, because that's in the solution set. You can always check it with something that's outside, but it'll be easier to check with something that's in the set. So negative 2 does fall between those. If we plug it back into our original inequality, we have 2 times negative 2 plus 5 inside of our absolute values. It's less than 3. 2 times negative 2 is negative 4, plus 5 is 1. The absolute value of 1 is less than 3. So 1 is less than 3, and we know that is correct. That is a true statement. So and I'll switch the color here just to make sure we emphasize the solution written on, graphically would be this open circle from negative 4 to negative 1, and then what we have written in the box here is the algebraic solution, which could also be written this way as well. Let's do the second one now. Now we're talking about things that are greater than 4 units from 0. Okay? Think about things that are greater than 4 units from 0. You're talking about things that are going to be more than 4 or less than negative 4. So remember, this one here is going to be a disjunction. Okay, so we're going to start out here. And the first step would be to take this and break this into the two inequalities. The first one looks exactly the same, except we don't have the absolute values. I know it's greater, so I'm going to say or. And then I'm going to say my second one would be the exact same thing from the inside, but then the opposite of greater than 4 is less than negative 4. I may need to move my number line here. So let me see if I can move these down a little bit. There we go. So we're going to solve these. I'm going to subtract 2 from each side. I'm going to have 3x is greater than 2. Divide by 3 and we get x is greater than 2/3. Or subtract my 2 here. I have 3x is less than negative 6. Divide by 3, I get x is less than negative 2. So I'm going to plot negative 2 on my number line, and I'm going to plot positive 2/3 on my number line. X is less than negative 2 is going to be an open circle going to the left. X is greater than 2/3 is going to be an open circle going to the right. And since they're going opposite ways, I can go ahead there and put the graph together. Remember, looking at the union of the graphs, so we're combining them. So our answers would be then x could be greater than 2/3 or less than negative 2. Has to be written as two statements. Can't write this as a compound inequality, so don't do that. To check it, you can take a value that's less than negative 2, say negative 3, and plug it in. We'll do that here. Let's change the color so you can see where it's coming from. So let's say negative 3 here. Alright, let's put in negative 3. We've got absolute value of 3 times negative 3 plus 2. That should be more than 4. That would be negative 6. I'm sorry, negative 9 plus 2 would be negative 7. The absolute value of negative 7 is greater than 4. That would be true because 7 is greater than 4. And then let's just choose a value. Let's just say like 1, right? 1 is greater than 2/3. We could plug that in, and I'm just going to, because I'm out of space on here, I'm going to just draw it in here. We'll say the absolute value of 3 times 1 plus 2 is greater than 4. 3 times 1 is 3, plus 2 is 5. The absolute value of 5 is greater than 4. Yes, it is. So you see how both numbers from either side here would make it true. So our solution set is correct. X is greater than 2/3 or x is less than negative 2. Couple more now. Let's look here. Now when we have an inequality that looks like this, the absolute value of 2u minus 1 plus 3 is less than or equal to 6. Okay, we're going to take this one and you're going to use the same method you used for solving the absolute value equations. Remember, we want to get our grouping symbols by themselves first. So we need to subtract the 3 from each side first. And now I have the absolute value of 2u minus 1 is less than or equal to 3. So the absolute value of 2u minus 1 is less than or equal to 3 can be broken into 2u minus 1 is less than or equal to 3. So same exact statement, just without the absolute values. Now, is this one a conjunction or disjunction? Well, if you said conjunction, you are correct. So we're going to be saying and because it's less than. It's less than 3. So we have 2u minus 1 is less than or equal to 3, and 2u minus 1 is going to be greater than or equal to negative 3. Now we'll solve each of these. We'll add 1 to each side. We'll have 2u is less than or equal to 4. Divide each side by 2. We get u is less than or equal to 2. And we add 1 here. We're going to have 2u is greater than or equal to negative 2. And we divide each side by 2. We're going to get u is greater than or equal to negative 1. Let's plot those on our number line here. We got negative 1 on the left side, positive 2 on the right side. U is greater than or equal to negative 1 is going to be a closed circle going to the right, because all the values greater than or equal to negative 1 would be on the right side of negative 1. And all the values less than 2 are going to be to the left. Obviously, they're closed circles because we're including those. And because it's a conjunction, we are looking for the overlap, which goes from negative 1 all the way to positive 2. So our solution set goes from negative 1 to positive 2. If we're going to write that algebraically, we would say that u is less than or equal to 2 and, less than or equal to 2, and u is greater than or equal to negative 1. That's one way, or we could say negative 1, that's our lowest boundary point, is less than or equal to u, and u is less than or equal to 2. To check it, maybe throw the value 0 or 1 into the inequality just to make sure it's true. Let's do that. Let's choose 0 here. We're going to switch colors. Let's say 0. That should fall in between. So we say 2 times 0 minus 1 plus 3 is less than or equal to 6. 2 times 0 is 0. Minus 1 would be negative 1. Absolute value of negative 1 is 1. Plus 3 is less than or equal to 6. We get 4 is less than or equal to 6, which is true. We know that we're correct. Yay! All right, let's move on. Next one, 4 minus the absolute value of 3k plus 1 is less than 2. Sorry, just get comfortable. Here we go. First thing here, let's not screw this one up. Let's go ahead here and do this to get our absolute value brackets by themselves. So we need to get rid of the 4, and you can treat this like there's a negative 1 in front of there if you want, but this is like minus all of this. I need to get rid of the 4 first. So I have negative 1 times the absolute value of 3x plus 1 is less than negative 2. If I want to get rid of the negative out here, I'm going to go ahead and divide each side by a negative. Remember that fancy little trick there that happens when you divide both sides by a negative. You're going to say the absolute value of 3k plus 1 is greater than 2. Remember, you got to flip your inequality there. So now we're going to take and break it into two statements. We're going to say 3k plus 1 has to be greater than 2. And because this is an or here, we're talking about something that's greater than 2 units from 0, this is a disjunction. We need to say or. So we're going to say 3k plus 1 is less than negative 2. Now we just solve each of those. Subtract 1 from each side. We've got 3k is greater than 1 divided by 3. And we get k is greater than 1/3. Or we subtract 1 from each side on this one. We're going to have 3k is less than negative 3. We divide by 3. K is less than negative 1. Put our boundary points on the number line. There's negative 1. There is positive 1/3. it's supposed to be greater than 1/3. So we're talking about open circle to the right. K is less than -1. We got open circle going to the left. Because it's a disjunction, okay, we don't have to worry about finding the intersection of the graphs because we're talking about the union. So what we're going to end up with here is K is greater than 1/3 or K is less than -1. If you have questions or concerns there, make sure you put a mark on that problem and you can ask about it in class. Let's go on to the last ones here. I know this video is starting to get longer than what I wanted it to be. Letter E, 4 plus 2 times the absolute value of the quantity 3t minus 5 divided by 2 is greater than 5. Again, we need to isolate the absolute value brackets first. So I'm going to subtract 4. So we're going to have 2 times the absolute value of 3t minus 5 over 2 is greater than 1. Now some people may think go ahead and distribute the 2 through. Others will want to divide by 2. It could go either way, but let's take it here and I'm going to just follow our rules that we've been following all along, getting the absolute values by themselves. So I divide each side by 2. I have the absolute value of 3t minus 5 over 2 is greater than 1/2. So because this is greater than, we're talking about disjunction, so we're going to break it apart. We have 3t minus 5 over 2 is greater than 1/2. Or 3t minus 5 over 2 is less than -1/2. If we multiply both sides by 2, you see we get rid of our fractions there, right? The first one, just to make sure that nobody gets lost. But really, the 2's are going to cancel. So really we just have 3t minus 5 is greater than 1. Add our 5, we got 3t is greater than 6. So t has to be greater than 2, or I thought I would do it. I wouldn't do it, and I did it. Oh well. 2's cancel out, right? We've got 3t minus 5 is less than -1. We add our 5 to each side. We're going to have 4. And we divide each side by 3. We should get t is less than 4/3. So if I put 4/3 on here, that's less than 2. T is greater than 2 would be an open circle going to the right. T is less than 4/3 would be an open circle going to the left. And because it's the union, because we're talking about or, either one of those would work. We don't need to find the intersection. That would be our solution. T is greater than 2 or T is less than 4/3. Plug in a value from either side to see if it's true. Last one, we're going to take it here, we're going to solve 2 times the absolute value of 2t minus 5 over 3. Then we have minus 3 on the outside is greater than or equal to 5. So let's add a 3. We have 2 times the absolute value of 2t minus 5 over 3 is greater than or equal to 8. Let's divide each side by 2. We now have the absolute value of 2t minus 5 over 3 is greater than or equal to 4. Looks like another disjunction. So we're going to take it and we're going to put our first statement as 2t minus 5 over 3 is greater than or equal to 4. So same exact statement as what we have down here, just without the absolute values. Or 2t minus 5 over 3 is less than or equal to negative 4. So the opposite of the inequality and the opposite of the number. Multiply both sides by 3, we're going to get 2t minus 5 is greater than or equal to 12. Add 5, you're going to have 2t is greater than or equal to 17. Divide by 2, you're going to get t is greater than or equal to 8.5, or 2t minus 5 is less than or equal to negative 12. So we multiply both sides by 3. We added 5 to each side and got 2t is less than or equal to negative 7. We divided each side by 2, and we got t is less than or equal to negative 3.5. Let's put those on our number line to see if there's anything crazy happening there. So greater than or equal to 8.5 would be a closed circle going this way. Less than or equal to negative 3.5 would be a closed circle going that way. So nothing crazy happening. Sorry to disappoint. So we take it there. And our solution could be anything less than or equal to negative 3.5 or anything greater than 8.5 or equal to 8.5. All right. So hopefully that's enough practice there to where you feel like you have an idea of what's going on. Remember, you can ask questions in class as we work through some of the assignment there together. Or, if you want to ask in math help beforehand, that's also great. But this is the notes for 4-6, absolute value inequalities, or absolute value in open sentences.